Here on Earth at sea level, the boiling point of water is about 212 degrees Fahrenheit. But up here in the mountains near Denver, we're at a higher altitude. We've got a lot less atmosphere pressing down on us, and so it boils at a lower temperature. Let's put a thermometer in here. There's 200 even right there. And that's a lot cooler boiling temperature than at sea level. Now, if you go to even higher altitudes, at 100,000 feet here on the Earth, the air pressure is about what it is on the surface of Mars. And on the surface of Mars, water will boil effectively ambient temperature. We wouldn't have to heat it at all. You just put a glass of water on the surface of Mars, and it'll boil and disappear away.
But the planet's surface tells us that dry Mars was very different in the past.
When you see things like river channels that probably took millions of years to carve, that gives you an idea that the atmosphere was once very, very different. It had to be thick to allow liquid water to exist on the surface.
To investigate what happened to that thick Martian atmosphere, MAVEN swings into action.
One of the main objectives of the MAVEN mission was to measure argon on Mars. There are slightly different kinds of argon. We call these isotopes. And basically it means that there's just an extra neutron in the nucleus. So there's one type of argon that's just a little bit heavier than the other type, just by one neutron, not by much.
High up in the atmosphere, MAVEN tag teams with Curiosity down on the surface. They measure the amount of light and heavy argon.
Now, what's special about argon? Well, argon is not very reactive. It doesn't really get involved in a lot of chemistry. It's not really absorbed by rocks, doesn't change much. Once it's emitted, it kind of hangs around.
And that makes it very valuable because it means it stays in pretty much its pristine, pure form through the history of the planet.
When the researchers back on Earth compare the readings from the two Martian robots, something doesn't add up.
With Curiosity on the surface, we see a certain ratio of heavy to light argon. And we expect that same ratio to exist up in the atmosphere. But with MAVEN, we see a different ratio. We see far less of the light argon than we do down on the surface. So something is messing with that ratio. The only thing we can think of that can mess with the ratio of argon is the solar wind from the sun.
The sun spits out a constant stream of particles called the solar wind. The wind is over 1 million degrees Fahrenheit and travels at up to 500 miles a second. When it reaches Mars, it strips away gases high up in the atmosphere.
The lighter the argon is, the higher it gets up into the atmosphere. That means that that gets blown away, preferentially, by the solar wind. The heavier argon stays a little bit lower down and a little bit more protected. So when you look at the ratio in the atmosphere of the light argon to the heavy argon, it gives you an idea of how much has been lost over time.
MAVEN's data reveals that Mars has lost 65% of the argon from its atmosphere, and the solar wind continues to bombard the planet.
The atmosphere of Mars is being stripped away by solar radiation by 1/4 pound every second.
This rate of atmospheric loss leads to one conclusion. The solar wind robbed Mars of its once thick atmosphere, and with it, the planet's water. But a question remains.
We know that Mars's atmosphere was much thicker in the past, really similar to Earth's. So why is it that Earth's atmosphere is still mostly there, whereas Mars's has been stripped away?
Earth has a protector, a magnetic field that shields our atmosphere from the ravages of the solar wind.
The Earth's magnetic field is generated deep in the core. There are actually two cores. There's a solid inner core and a liquid outer core. And that solid inner core is delivering heat to the outer core. And as it does this, it causes convection currents.
The convection currents pull electric charges around and cause magnetic fields to fold in on themselves. We call this a dynamo, and this is what's capable of generating powerful magnetic fields.
The magnetic field forms a protective bubble around Earth that deflects the solar wind away from our planet. Did Mars once have its own force field? To find out, Maven homes in on some ancient volcanic rocks on the Martian surface. It detects faint magnetic traces.
Martian rocks, typically in the form of lava, become magnetic when the iron particles in the rocks become aligned with a magnetic field that's active at the time, and then as the rock cools, those things get frozen in place. That sort of freezes a magnetic field into place.
What that tells us that these volcanic materials were erupted at a time where there was a magnetic field present on Mars.
Dating the magnetized rocks reveals that Mars had an active magnetic field for almost 1 billion years.
This means that the atmosphere of Mars was protected for those billion years. And if the atmosphere was protected, the liquid water was protected. And if that liquid water was a home for life, then that life was protected.
But something happened to bring Mars's force field down. To discover what, our quake specialist, InSight, is ready to burst open the mystery of the planet's lost protective shield. Robots are rewriting the history of Mars. Now, InSight probes the planet's interior. Its mission? To discover if the secret of the planet's lost magnetic field lies beneath the Martian surface.
InSight was developed with the world's best seismometer. This is a really precise, really delicate, really sensitive instrument. And it just was placed on the surface and started listening.
2021. InSight listens for seismic vibrations called Marsquakes as they travel through the planet's interior.
It's detected quite a few Marsquakes, but these were very small. But then it detected 2 much larger ones. And these were interesting. Not only were they more powerful, but they were coming from the direction of Cerberus Fossae, which is a very interesting region on Mars.
The magnitude 3.1 and 3.3 quakes came from Cerberus Fossae, a series of trenches that stretch for 750 miles across the Martian surface. Some fissures cut through impact craters that are only a few million years old. This means Cerberus Fossae must be younger. InSight teams up with the Mars Reconnaissance Orbiter, flying hundreds of miles above. This eye in the sky spots an ancient lava flow spreading out over a 3-mile area. Dating of the flow reveals that it's recent.
The Mars Reconnaissance Orbiter spotted in the Cerberus Fossae region some lavas that appear to be about 50,000 years old. This is crazy young for Mars.
Mars has been around for billions of years. 50,000 years is nothing. Humans were around on Earth that long ago, so this is really recent.
Looking closer at these images, scientists learn this explosion was most likely a violent pyroclastic eruption.
A pyroclastic flow is kind of like taking a soda can and shaking it up and opening it up, right? There's dissolved carbon dioxide in the liquid, and when you open it up to the atmospheric pressure around it, that gas expands rapidly and you wind up getting a face full of soda. Imagine now that your can of soda is 5 miles high and 3,000 or 4,000 degrees.
The Cerberus Fossae eruption was really pretty big. It was a 20-mile long fissure that opened up, and then a huge jet erupted out of that. It probably went tens of miles up into the sky and then blanketed an 8-mile region all around it. Based on the fact that we had these 2 Marsquakes recently, plus the evidence of the volcanic eruption just 50,000 years ago, I mean, now we cannot say that Mars is dead. We have to say Mars is active.